Hi, I'm Jason Jelks, Manager of Software Development for Sensory Analytics. In this video series, I will guide you through the basics of Kepware tools, how to set up a data tag, as well as how to connect the SAOPC server and/or plant PLC networks to the SpecMetrix system. In this second video, we're going to review SpecMetrix data organization and structures. The SpecMetrix data is organized by the SpecMetrix line. That contains everything that is about a specific configured line, which includes all the inputs, the outputs, probe information for one or more probes, and traversing status. Plant inputs include things such as the automation control, the recipe override if you're going to change the graph structures, lane override if you're wanting to include web dimensioning and partitioning, and then some extra traversing commands for traversing-based systems. The SpecMetrix output includes all the operating outputs. In other words, what recipes, base codes are actually being measured in this particular run, including the details about the recipe and base code settings for those particular recipe objects, and the line status and probe measurement data. And lastly, alerts and messages that come through based upon any kind of condition or event that needs to be signaling information. Specifics about the plant inputs. The most important plant input for the SpecMetrix system is the recipe name. That is a name in which has been defined in the SpecMetrix system. When we look at a recipe name, we are editing something in the data manager that would include anything that's in this particular list. And the name, as it shows in this list, is exactly the name that needs to be sent across. That includes any kind of spaces. It is highly recommended not to use any special characters that would conflict with a Windows file name, such as slashes, colons, so anything that's going to be a problem in a Windows file name is suggested not to use. The length of a file name is completely dependent upon your PLC and the maximum length that a PLC can use. Typically, we recommend keeping names as succinct as possible, so perhaps around 20 characters or so. A base code is basically a recipe that is used for creating a subtractive amount as a constant. It does not subtract in real time. It is essentially subtracting off the evaluated thickness in microns from the measured recipe as it's coming through as a total thickness value. Next is a tracking ID, and this tracking ID is used in the file name as well as stored in the CSV, and allows tying a specific run or a particular coding from the point at which a splice has gone through. And each time that the stop command is signaled, any of these values can be changed and set up. Once the start has begun or a run bit has been set to true, then there is no ability to change the recipe, base code, or tracking ID once the start has commenced. You would be required to stop or set a run bit to 0. Lane definitions, again, those are similar to a recipe, and those are also defined in the data manager. And here, the way you can define this as a naming convention could be an integer value or decimal value, something like that, that is going to define perhaps a web width, and that web width is respective to what you're measuring. That could be in millimeters or inches, and allows you to define not only what the web width is, but how many lanes you want to divide it into and what sizes you want these particular lane widths to be. In this case, I've got a 12 to represent 12 inches at 1 inch width intervals. I've also got a lane width at 1200 to be millimeters with 100 millimeter intervals. So that there's nothing that indicates what the restrictions are, but you should keep in mind what you're setting your values to are respective to what that particular line is measuring. And lastly, the most important one, aside from the recipe name, is the run bit. Setting a run bit to 1 does not mean that we are automatically going to begin measuring. What that means is that it's going to request that SpecMetrix validate the recipe name, base coat name, and tracking ID and lane definition that have been input from the PLC. If the run bit comes from the PLC, the recipe, base coat, and information has to come from the PLC. It will not start running based upon remote location. That is not a dependency relationship. The next part is that when you're setting your run bit to 1, you do want to measure and monitor the line state is running bit. When that is set to 1, then you know that the SpecMetrix PC is in the process of measuring. Ideally, when you have set your run bit from 0 to 1, the line state, you would be able to see that it changes from 0 to 1 as well, as a good indicator that things have started. For the probe outputs, the probe output container, as far as probe data, holds a number of probes. It can be one probe, especially for traversing systems, but often for our fixed probe inline, it may be 2 or 3 or 4 probes that are contained in this probe container. Each probe gets assigned a name, which is unique to a particular line in the SpecMetrix line. And each probe holds the measurement value, micron value, read status, and integration time. All those values are passed across when the probe is reading. In the event that a probe during its cycle time, which is a default by 1 second, does not evaluate a successful reading, it will set the read status to something other than 0. When it's 0, the measurement value and micron value are good. Those should be considered valid measurements. When the read status is anything other than 0, then those values should not be used to provide to your historian or any other data. Those should be considered bad values. There are other considerations that we can provide based upon administrative settings that will allow the measurement and micron value to be set to 0 whenever there is a bad reading. Other options allow it to remain static from its last value taken. Alerts and messages include things such as an enumerated code that is used in SpecMetrix that defines what a particular failure is, or a condition is, or an alert, or an alarm, as well as we provide the name of that particular enumeration string as an output. We also provide the last updated date and time stamp in a string format that allows you as the end user or PLC monitor to be able to understand when that particular instance occurred. And lastly, there is quite often a message, a text message that will come across on that screen that allows the PLC or end process to display that message in a user readable format. Because many PLCs don't have language ability for translation, this particular function is limited in English as text at this time. Any message that is posted will remain there until the next message gets posted through. So it is important to remember, if you look at this particular value, you do pay attention to the date and timestamp, as if there's never been a problem that's happened in the last week, the last date and timestamp of an error message may have been a week ago. So keep an eye on that date and time. Make sure that it is a current event. On the SpecMetrix tag list, some important notes to recap is each SpecMetrix line is independent data and should have a separate device, or at least minimally a separate container, to keep the data logically associated with each line. Each container or folder, as you break down the line progress, should be considered a separate UDT structure or user-defined data type. Or it may be a container of UDTs, such as the probe data containing multiple probes. And each probe in of itself, as you're evaluating, should have its own data structure. So you should not share probe data type amongst multiple probes, even if you do have some switching mechanisms where you're utilizing maybe a single physical probe for multiple spectrometers. Technically really should create a separate line and a complete set of UDTs so that you can know that the data belongs to that field or not. And if you need a full list of the SpecMetrix data fields, you can always request what the current list is by emailing support@specmetrix.com, and we can get that list to you. As things kind of grow and continue to improve, we do, as a company, continue improving and making changes and additions to these fields. The additions do not necessarily require any change on plant part to make that, but they do become available with each upgrade software. In the next lesson, we will discuss importing tags for OPC using predefined Kepware and OPS structures, and finally mapping the SpecMetrix inline systems with the Kepware tags that we've created. Thank you.